Hello, this is question 9 on your June 2022 paper 3 from AQA. It's a proof question and it's not difficult, but it's a bit strange. I think it's the wording. Assume that A and B are integers, such as this happens. Yeah, prove that A is even. So this first part is quite straightforward. So we have if we have to prove that A is even, we are going to separate A. So we are going to leave A squared as the subject, so it's 4b plus 2, which means if we factorize, then we have 2b plus 1. That means that a squared is even because it can be written as 2 times something else, so it's going to be even. So this means a squared is even, and we know that if a squared is even, a is even. We could deduce that and get the marks, but I'm going to show you how to prove that when a squared is even, a is even, just in case. And I would add, I think it's very short proof. I think you get the marks just with this, is what the mark scheme says, but if it's more marks, I would definitely prove that when a squared is even, a is even. Yeah, so let's go into do that. We are going to prove it by contradiction. It's a typical example of proof by contradiction. So our contradiction is going to be that when a squared is even, a is odd instead of even. Yeah, so this is our contradiction. If a is odd, that means I can write as 2n plus 1, for example. Yeah, when I square it, yeah, a squared, so I can write a squared is going to be 2n plus 1 squared, just because a is that. If I expand that bracket, I have 4n squared plus 4n plus 1. That can be factorized as 2n squared, 2n plus 1. This is even because it's something multiplied by 2. Plus 1 is odd. Yeah? So this is odd. And this is a contradiction because we say that a squared was even. Yeah, so this is a contradiction. Therefore, a must be even. I'm just explaining you so you know how to prove that when a squared is even, a is odd. A is even as well. Yeah, so I can add here at the top that a is even. That's what I wanted to prove. Yeah, so this is like a note, but you would get the marks if you just write this. Second part is the one that I think is a bit confusing. Second part says, hence, so we are going to use that a is even, prove that 2b plus 1 is even, and explain why this is a contradiction. So hence, just remembering that a is even. So if a is even, that means that we can write it as 2m, for example. Then 2 times another integer. We know, so from here, that a squared is 2 times 2b plus 1. Yeah? So we can write that a is 2m squared must be equal to 2b plus 1. Yeah, just substituting here my a by 2m. If I square this, I have 4m squared is going to be 2 times 2b plus 1. Simplifying or dividing by 2, that means that 2m squared is going to be 2b plus 1. So 2b plus 1 is equal to 2 times something, which means that 2b plus 1 is even. Yeah, so that means that 2b plus 1 is even. But we know that 2 times something, an integer, plus 1 is odd. Yeah, so but 2b plus 1 is odd. So this is a contradiction. That's what they wanted us to say. Contradiction. That's the contradiction that we are trying to find. Yeah. Explain that why that's a contradiction. That's what you have to do. And then the last thing is explain what can be deduced about the solutions of this equation. So this equation is what we started with. So for that equation to be possible to happen, a squared would be 4b plus 2, yeah? And this cannot be because it's a contradiction. It's what we just proved here, yeah? We decided that a must be even, yeah? So this equation is telling us two things. One, that a must be even, but at the same time it's telling us that in that case 2b plus 1 is even, but we know that it's odd, so it's a contradiction, which means this cannot happen. Yeah, this equation is not possible. There is not integers that satisfy that one integer square is equal to 4b plus 2. Yeah, because it's a contradiction, and we have proved that. So we can say that there are no solutions. No, there are no solutions to these equations. Well, integers. They say that we are talking about integers. Yeah, we could get probably fractions or decimal. They are not two integers. I would say they are not two integers that satisfy the equation. And that's all. Yeah. So that's, I think it's a bit a strange question, proof question, but that's it.